In this video is going to go over the inverse sine, cosine, and tangent functions. Remember, for any function f of x, the inverse function we denote with a -1. That does not mean the reciprocal. What it means is it undoes our original function to where if you compose an original function with its inverse, it equals x. Likewise, if you compose this, you do it the other way, plug in the original function into the inverse, you just get x again. Both of these have to work in order for it to be an inverse. Right, it might be worth noting that a function and its inverse are reflections across the line y equals x. So now we're going to discuss how all this applies to the sine, cosine, and tangent functions. For the function y equals sine inverse of x, let's first look at the original sine function. Alright, this is our original sine function. And notice that the domain is technically all real numbers, but if we let the domain be all real numbers, then it fails what we call the horizontal line test. If you've forgotten what the horizontal line test is, in short, it means what it says is an inverse function exists if a horizontal line crosses through the graph only once. You see how if we look at the domain of sine of x as all real numbers, this random horizontal line fails the horizontal line test. But if we restrict the domain to being from -π/2 to π/2, then it would pass the horizontal line test, and we could come up with an inverse function. So if we restrict the domain to being from -π/2 to π/2, and restrict the range from -1 to 1, then we can come up with an inverse. Remember, for an inverse, the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. So if the domain and the range are switched, you notice for our original function y equals sine of x, the range was from -1 to 1, which means for our inverse, y equals sine inverse of x, the domain is from -1 to +1, and the range is from -π/2 to π/2. And y equals sine inverse of x means x equals sine of y, so you flip the x and the y's. Alright, find the exact value of an inverse sine function. And it says to find the exact value of sine inverse of 1. Alright, so if you want to rearrange this, if you want to take the sine of both sides, sine of y is equal to sine of sine inverse of 1. The sine and the sine inverse undo each other. So what y equals sine inverse of 1 means is what angle has a sine value of +1. Remember, for the original sine function, the domain is from -π/2 to π/2. Actually, that's the range of our original sine function. Or actually, that's the range of the inverse. It's the domain of our original sine function. But the y's and x's are still in terms of the inverse, so we're talking about the y values being from -π/2 to π/2. Now, the sine is positive 1. Since we're talking about negative pi over 2 to pi over 2, let's figure out first what quadrants those are talking about. Negative pi over 2 is down here in the negative y-axis. Positive pi over 2 is up here in the positive y-axis. So we're talking about the first and fourth quadrant. And since sine is equal to 1, which is positive, it's positive in the first quadrant. Now, sine is 1. It ranges from negative pi over 2 to pi over 2. If you remember from the unit circle, at pi over 2, on the unit circle the point is 0, 1, so the sine value is 1. So, the particular angle where sine is 1 is at pi over 2. Alright, here's another example. Let's find the exact value of sine inverse of negative 1/2. Alright, when it's talking about sine inverse of negative 1/2, it's asking you what angle. So instead of y's, we can just use theta. What angle gives you a sine inverse of negative 1/2? So if you want to take the sine of both sides, you have sine of theta is equal to sine inverse of negative 1/2. So the sine and sine inverse undo each other, so you have sine of theta is equal to negative 1/2. Remember, theta goes from negative pi over 2 to positive pi over 2. So remember, sine is negative in the fourth quadrant. So we're going to find out what angle in the fourth quadrant gives you a sine value of negative 1/2. Now, you may remember this as an angle for when sine is 1/2, that the angle would be would have a reference angle of 30 degrees, so pi over 6. But since it's in the fourth quadrant, the angle that is 30 degrees below the x-axis would be at 330 degrees, like all the way around here, 330 degrees, or I think that'd be 11 pi over 6. You can check your unit circle to make sure, but I'm pretty sure it's 11 pi over 6, or 330 degrees. So, for the next example, we said when you compose a function with its inverse, you just get what you had inside because the function and the inverse undo each other. Likewise, if you compose the inverse of the function with the original function, do it the other way, you still get the same thing because the function and the inverse undo each other. So for part A, sine inverse of sine of pi over 8, you just end up with pi over 8. Likewise, for part B, sine. Now you would think to do the same thing, just write your answer as 5 pi over 8, but remember, we're talking about sine inverse on the outside, so for sine inverse, remember the range is contained from the values of negative pi over 2 to positive pi over 2. And that would be negative 4 pi over 8 to positive 4 pi over 8. So this is outside of our range. So we need to find an angle that's inside our range, to where sine of 5 pi over 8 is equal to sine of our angle. So to draw you a little diagram, 5 pi over 8, you can tell is between pi over 2 and pi over 2 is 4 pi over 8. Pi over 2, which is on the positive y-axis, is 4 pi over 8. Pi is on the negative x-axis, so you know it's somewhere in this angle. 5 pi over 8, you notice that's 3 pi over 8 above the x-axis. The 5 pi over 8 is 3 pi over 8 above the x-axis, and since the sign is positive, you could go in the first quadrant and take the angle that's 3 pi over 8 above the x-axis. That would tell you sine of 5 pi over 8 is equal to sine of 3 pi over 8. Because they're both 3 pi over 8 above the x-axis, and they're both positive. So, sine inverse of sine of 5 pi over 8 is equal to sine inverse of sine of 3 pi over 8, and that would just be equal to 3 pi over 8. Alright, so now we gotta do it the other way. What is the sine of sine inverse of 1/2? Alright, remember the input for the inverse sine function is between 1 and -1. And 1/2 is obviously within that interval, so sine and sine inverse cancel out. So for part A, it'd just be 1/2. Now for part B, the domain of the function contained between the x values -1 and +1. So this value of 1.8 is not in our interval, so that would be undefined. So now y equals cosine inverse of x. Alright, this is the graph for the original cosine function. Now, you notice if you do a horizontal line test, the cosine function would fail the horizontal line test at multiple points. I use the horizontal line y equals -square root of 2 over 2 as an example. So if we restrict the domain from 0 to pi, then it would pass the horizontal line test, and thus you could do an inverse. And of course it's contained between the y values -1 and 1, so if you take the inverse, you would have the following information. Right, you have this information about cosine inverse. Y equals cosine inverse of x means the same as x equals cosine of y. And the domain for cosine inverse is just from -1 to 1. And the range for cosine inverse is from 0 to pi. So, the exact value of cosine inverse of 0, which is what we're defined in example 6. Remember, when you take an inverse trig function, it gives you a particular angle, so you want the angle that you get whenever you take cosine inverse of 0. And if we take cosine of both sides, you have cosine of theta equals cosine of cosine inverse of 0. The cosine inverse cancel out, so you have cosine of theta is equal to 0. Remember, the theta is contained from 0 to pi. So what angle from 0 to pi gives you a cosine value of 0? So if you remember on the unit circle, it's from 0 to pi, so it would be from 0, the first and second quadrant, because that's 0 and that's pi. If you remember at pi over 2, on the y-axis that's the point 0, 1, so the cosine is 0, so theta would be pi over 2. For example 7, it says find the exact value of cosine inverse of -square root of 2 over 2. Remember, that's asking what angle do you get when you take the inverse cosine of -square root of 2 over 2. So if you were to take cosine of both sides, that'd be cosine of theta is equal to, you'll end up with just -square root of 2 over 2, if you haven't learned by now. And since cosine is negative, that would be in the second quadrant. And if you look on your unit circle, the angle or rather, the angle here, that would give you that cosine value would be 3 pi over 4. Because the angles that give you a cosine value of square root of 2 over 2 of any form would be multiples of pi over 4. So you know your angle would be 3 pi over 4. Alright, so for example 8, yes, find the exact value of the following for composite functions. Part A, it asks for cosine inverse of cosine of pi over 12. Now since pi over 12 is contained from 0 to pi, I don't know why I do the line underneath. Since it is contained from 0 to pi, part A, that would just be pi over 12, because the cosine inverse and cosine would undo each other. For part B, alright, remember the domain for cosine inverse is from -1 to +1. So, that would be just cosine of cosine inverse of negative pi over, or negative 0.4 would just be negative 0.4. Now for part C, cosine of negative 2 pi over 3. Negative 2 pi over 3 is not in this interval. It is down here. It's 2 pi over 3 negative. So, what you can do is find the corresponding angle in that interval. You know in the first quadrant, the angle that's 2 pi over 3 away from the x-axis would just be 2 pi over 3. And so, you could say for part C that cosine inverse of cosine of negative 2 pi over 3 is equal to cosine inverse of cosine of positive 2 pi over 3, which would just be 2 pi over 3. So now for part D, we have cosine of cosine inverse of pi. You notice the domain for cosine inverse is from -1 to +1. Since pi is not in that domain, it would be undefined. The reason why we just say undefined, we don't try to find any angle that corresponds with that. You would need to look at the graph of cosine inverse. I will put the graph of cosine inverse up now. Alright, here's the graph for cosine inverse. You'll sometimes see it written as arc cosine. Alright, the domain, the graph is limited from -1 to +1. So if you notice pi, which would be way the heck out there, is nowhere even close to being in the domain. So that's why it's undefined. Now for tangent inverse of x, which you'll sometimes see rewritten as y equals arc tangent of x. So here's the graph for y equals tangent of x, with the domain being from -infinity to +infinity. But with x not being equal to odd multiples of pi over 2. So, you notice it would fail the horizontal line test at infinitely many points. So, if we limit the domain to just one branch, say right here, so if we limit the domain from -pi over 2 to pi over 2, let the range be all real numbers, then we would get the following information for the inverse. We get y equals tangent inverse of x, which is the same as saying x equals tangent of y, And for tangent inverse, the domain would be the set of all real numbers, and the y values would be from negative pi over 2 to positive pi over 2. But they cannot be equal to there because for the original function tangent, that's the location of the asymptotes. So for example 9, to find the exact value of these functions, tangent inverse of 1. What angle do you get when you take tangent inverse of 1? So if you do tangent to both sides, you have tangent of theta is equal to tangent of tangent inverse of 1. Now for tangent and tangent inverse undo each other, so you have tangent of theta is equal to 1. So that's asking you what angle gives you a tangent value of 1. And you know, since tangent is positive, that'd be in the first quadrant. And in order to do that, in order for tangent to be equal to 1, that means sine over cosine has to be equal to 1. In order for sine over cosine to be equal to 1, the sine and cosine have to be equivalent. They have to be the exact same thing. That only happens when theta is pi over 4 or 45 degrees. Alright, so for part B is asking what angle do you get when you take tangent inverse of negative square root of 3? Alright, if you follow the same thing as in part A, you get tangent of theta is equal to negative square root of 3. And so you want the angle whose tangent is negative square root of 3. Tangent is negative in the fourth quadrant. So you're looking at all the angles from 3 pi over 2 to 2 pi that give you that tangent value. So you need to find the values of sine and cosine on your unit circle, sine over cosine. Now when you divide them, you would just get negative square root of 3. Just so you know, it's equal to negative square root of 3. If you look on the unit circle, it'd be when the sine is square root of 3, negative square root of 3 over 2, and the cosine is positive 1/2. So it'd be at the point 1/2, negative square root of 3 over 2 on your unit circle, which would be at, which means your angle would be at 300 degrees, or 5 pi over 3. So for example 10, you're asked to find the inverse function of f of x equals 2 sine of x minus 1. We limit the domain from negative pi over 2 to pi over 2. So at negative pi over 2, the range, if we plug in negative pi over 2, the left endpoint of the domain, let's figure out what the corresponding y value is. So it'd be 2 sine of negative pi over 2 minus 1. So sine of negative pi over 2 would be at negative 1 times 2 would be negative 2 minus 1 would be at negative 3. And f of pi over 2 would be at 2 times the sine of positive pi over 2 minus 1. Pi over 2 is at positive 1. Multiply that by 2. 2 times 1 is 2. Minus 1 is 1. So that tells you the range of our original function is from 1 to 3. Actually, it would be from negative 3 to 1, rather. Because if you notice, the 2 in front of sine of x means it stretches from negative 1 to 1, all the way from negative 2 to positive 2. But since you're subtracting 1 on the end, that means you shift everything down 1 unit. So instead of it going from negative 2 to positive 2, it would go from negative 3 to positive 1. And the domain would still be negative pi over 2 to positive pi over 2. So now to find the inverse, you can start off by writing it in terms of y equals 2 sine of x minus 1. Swap the x and the y's. Now you need to add 1 to both sides. We're trying to get the sine of y by itself so we can do sine inverse. So you have x plus 1 is equal to 2 sine of y. And so now, if you multiply everything by 1/2, you have 1/2 times x plus 1 equals sine of y. So if you take sine inverse of both sides, you have that the inverse is equal to sine inverse of 1/2 times x plus 1. So the domain, remember the domain is the same as the range of our original function. So the domain would be from -3 to +1. And the range would be the same as the domain of our original function. So it would be from negative pi over 2 to pi over 2. So here's example 11. It says solve the equation 3 sine inverse of x is equal to pi. Let's get sine inverse by itself. Divide everything by 3. So you have sine inverse of x is equal to pi over 3. So, if you want to take sine of both sides, that means x is equal to sine of pi over 3, which would just be, sine of pi over 3 would just be, I think it's square root of 3 over 2.